So now that we've talked a little bit about interest, let's go a little bit more into depth, more specifics. So for interest, typically A is the amount at the end after 2 years. P is the principal, that's your initial investment. R is your interest rate per year. N is the number of times that it's compounded each year. And T is the number of years. So for compound interest, the amount that you have will be equal to the principal times 1 plus rate over number of times it's compounded times the number of times it's compounded times the number of years, or to the power of that. So this should look familiar. It's a little bit like our definition of E, 1 plus some number over n to the n. That's basically what we called E when as n goes to infinity. That was the definition of E for the most part. So this R becomes the power here. T stays the power there. But the rest of that becomes E if you talk about continuously compounded interest. That's why that definition of E has to do with continuously growing. So, and if you just multiply by how much you started with, that's how much it will grow. So that's how much you'll have at the very end. So now let's look at this example. It looks like one example, but it's really several. If you invest $3,000 at 12% interest, find the amount you will have after 3 years if the interest is compounded annually, semi-annually, quarterly, monthly, daily, and continuously. So we're investing $3,000, so our principal is $3,000. Our interest rate, R, is 12%, which is 0.12. Our time for total is 3 years. So now we just need to look at our formula, which was A equals P 1 plus R over N to the NT. And we can replace that with E for continuously. So for annually, that's once per year. So remember, N is the number of times per year. So our principal is principal is 3,000, and it's after 3 years, so it's A of 3. Principal is 3,000 times 1 plus R, 0.12, over N. N is for annually 1 time, time to the power 1 times 3. If you simplify that out, that's 1 plus 0.12, so 1.12 to the 3rd power. So that would be 1.404928 times the 3,000 gives us a grand total of $4,214 and about 78 cents. If you're to do semi-annually, that just means twice a year, basically, every 6 months. We get the amount after 3 years of our $3,000, 1 plus 0.12 still, but now it's compounded twice. So it'll be to the 2 times 3 years. You get $4,255.56. If we switch now to quarterly, that means 4 times a year. Our amount after 3 years, when we invest $3,000, 1 plus 12% interest, 4 times a year. 4 times a year times 3 years. So that's to the 12th power. 1.03 to the 12th power times 3,000 is $4,277.28. Now let's try check monthly. So that means it'll be compounded 12 times in a year. $3,000, 1 plus 0.12, compounded 12 times. 12 times times 3 years. So that's 1.01 to the 36th power times 3,000 is $4,292.31. You can begin seeing that the more frequently it's compounded, the more interest you earn. Or you could think about the other way around, the more interest you would have to pay if it was a loan of some sort. If it was compounded daily, that means it's going to be compounded 365 times a year. 1 plus 0.12 over 365 to the 365 times 3 power. You get $4,299.73. Now, daily isn't quite continuously. Continuously means every second of every minute of every hour of every day. You can even go as far as saying every millisecond. So we have to switch and use PE to the RT for our formula. So if it is continuously, it's now the amount after 3 years of our principal still. But now it's E to the RT. R is 0.12. T is 3 years. So that's E to the 0.36 times 3,000. And that works out to be $4,299 and I'd have to round up to 99 cents. So compounded continuously is the most. You can see it's pretty close to compounded daily, but a little bit more. And I believe that most banks would actually use the continuously compounded interest function because they'll make more money on your interest.